Welcome friends and family. In this video I'm gonna teach you about Prolog. Specifically, I'm gonna teach you about the following purpose of my script, which is I need to show that Prolog is able to use DFS, which it means depth first search through the means of backtracking. So in previous video I talked to you about recursion. We talk about facts as well in other videos. So facts are just like any other facts in science, for example, or any other subject. For example, here I have a couple of facts. Specifically, I have 5 facts. Here what I'm saying, for example, is that Jessica is a parent of Bob. Here I'm saying that Sam is a parent of Alice. Mary, parent of Jessica. Mary, parent of Sam. John, a parent of Mary. So what I want to show is that when you run a query, when you run a query about a and you call a rule, which I'm gonna write here, rule for these facts, specific facts. Prolog uses depth first search through means of backtracking, and I'm gonna show you what I mean by this. So first, let's write the rule. So I'm gonna call the rule ancestor. So I'm gonna call ancestor a rule that says that if x, the variable x, or in other words the name x, is an ancestor of y, then that means that parent so the first rule states that if x is an ancestor of y, that means that x, the rule says that x is a parent of y. And that makes sense in real life. For example, if Jessica is a parent of Bob, that means that who's the ancestor of Bob? Jessica. That means that when I run a query about calling for the ancestor of Bob, I should get Jessica. But I'm going to show you that when you use recursion, you're backtracking. You are using depth first search and backtracking through means of backtracking. So I'm going to extend so I'm going to call this a recursive rule. And I'm going to say that so if x is an ancestor, so the way that I'm going to use this recursive rule is that first I need two clauses. First I need this rule, the first rule, and then I need a second rule. The second rule says that if x is an ancestor of y, if parent, that means that x is a parent of z and ancestor z y. I hope the syntax is correct. Okay, that means here I'm saying that so that the second rule says that if x is an ancestor of y, that means that if x is a parent of z and z is a parent of y, and then I keep recursively doing this rule by putting this here ancestor, and then goes back to here ancestor, and then here until I find all the ancestors of the call of the argument I make in the query. Okay, let's see if I get any errors right now, just to make sure we have the right. Save it. I don't have anything. Okay. Okay. So the next part is I'm gonna do the actual. I'm gonna show the backtracking. So let's do a query. The query says that ancestor of what are the ancestors of Bob? Okay, so the first ancestor of Bob is Jessica, and that's what it is here. So these facts were put into a stack. That means that whatever is on top, it is backtracked. So it's backtracked to what was first put into the stack. If I don't find anything at the top, for example, Jessica was found first because what's the first ancestor of Bob? The top says that Bob, the ancestor of Bob is Jessica. So what do you think the next ancestor? If I have Jessica as my current ancestor, if I keep going, the next one I should look back up. If I look, so I look here, Jessica. What's the ancestor of Jessica? Mary. So if I put semicolon here, I should get Jessica. So what's the ancestor of Jessica? The ancestor of Jessica is Mary. And what's the ancestor of Mary? John. So the next one, let's see, Mary. Let's see, false. Okay, let's see. I'm concerned about this. I'm not sure the syntax. I always, let me see, syntax. Okay, yes, it needs a comma. Okay, I think I know why. Because I compile it, save it, but I think I didn't make it. Let me see, make done. Okay. Okay, so now let's run the query again. Jessica, John, Mary, false. Okay, so we did it right the first time. Okay, so let's look at what it says here. So I said, what's the ancestor of Bob? And I put it in the variable x. Okay, so what's the variable? So okay, what's the ancestor of Bob? Jessica. What's the ancestor of Jessica? He says that it's John. He says that it's John. Because look, Mary, John. But see, what I'm curious is that this tells me here that the order in which it was pulled up. Here, for example, okay, John. Okay, now Mary. Okay, what's the ancestor of John? So basically, the way it was displayed was, let me see. Oh, I see. I think this one here should have been Z, and then here it should be that is correct. Yes, that is correct. Yeah, I think I got it right. Yes. Let's do something else. I want to do it a little different. Instead of having X here, what I'm going to do is I'm going to change the name so that way there is no conflicts. Hopefully that will give me a better result. So I'm going to call it T. Okay, so I haven't used that variable. So let's see what happens. Okay, so now first one, Jessica. Ancestor above, Jessica. Okay, so now let's go to the next one. Ancestor of Jessica says John. So in that case, it didn't matter. Okay. For me, for me to understand this easy, it would have made more sense if John were here and Mary here. In other words, the order that it was displayed. Okay, so to me it seems like we got it. It's just that I don't like the order that it was displayed. Like I said, it would make sense if Bob, Jessica, then Jessica, Mary, and then Mary, John. That would make more sense to me. Okay, so remember, so let's put the query that I use here. The query that shows the first search is going to be this one. Remember, let's say Bob, so let's say that when you run the query Bob, there weren't any Jessica. What do you think would happen? It would use backtracking. It would go to find the next possible relationship between parent and child. For example, it will go to find another Bob here, but we don't have any, so it stick to Jessica. So let's see what happens if I have this one here. I'm curious about this. So let's say you have another fact. It says that Bob Chloe is a parent of Bob. Okay, let's see. Compile. Okay. Now we run the same query, Bob. So we should see, we saw Jessica first, then we saw Chloe, then we saw John, then we saw Mary, then we saw, okay. So as you can see, the way that is being displayed is not the best way to display, but to me. But now this is more clear because it goes level by level, like I said, depth first search. Because look, it first find, the first that it found was Jessica, the ancestor above, the parent above is Jessica, but it also find Chloe, so it had two paths to choose from. Then it went to the first path, Jessica. He says John, and then from John went to Mary. Okay. So you can see that it does show that that Prolog does backtracking. It looks for different paths. So let's say I want to add another one. Let's say I want to add something like this. Parent, let's say Carlos, Chloe. That means that when I do that query, I should be able to see Carlos as part of my ancestors. So let's see. Okay, let's see now. Let's do it again. Okay, 1 second. Okay, first one, Jessica. Then I should see Chloe. Then I should see John. Then I should see Carlos. That is correct. Then I should see Mary. That is correct. So this indeed shows depth first search. And of course it's done through the means of backtracking. So it goes level by level. Okay, so that's what I wanted to show you on this video, and I hope you learn a lot. I hope you learn about depth first search through means of backtracking. Thank you very much. Don't forget to subscribe. You really help me a lot by supporting my channel.